Now let us talk about transpose and what a transpose of a matrix is. So first of all, a transpose of a matrix is denoted by A, and there is a superscript which is just written as T. Now, how is the transpose obtained? It is simply obtained by swapping the rows and columns of a matrix. So for example, if I have a matrix which is A, again let me take a 3 cross 3 matrix. Let's say if I have A, B, C, D, E, F, G, H, I, then what would its transpose become? Its transpose would be A, B, C, D, E, F, G, H, I. I hope you all can see how I've converted the row into a column. So if you look at the first row, it has been converted into the first column here, A, B, C, and the second row has been converted into the second column here. The third row has been converted into the third column here. So this is how a transpose is calculated. Now let's say, for example, initially the matrix was 3 cross 3, and after taking out the transpose also, my matrix remains 3 cross 3 order only. Now let's say if my orders were different. Let's say my rows were not equal to column. If I did not have a square matrix, I had an M cross N matrix, then after taking the transpose, my order would change to N cross M. For example, here you can see this is a 2 cross 3 matrix. After taking the transpose, you can see this row has changed into this column and this row has changed into this column. So now the number of rows has become turned into the number of columns, and number of columns have turned into the number of rows. So here we have 3 cross 2 matrix. So this is how transpose is calculated. Now let us look at a few addition and additive properties of transpose. Let's say if I'm taking the transpose of already taken transpose of a matrix, then we simply get A. Again, it is very simple. You all can check it out. Let's say this is my first matrix A. If I find out A transpose, what is it going to be? A, B, C, and D. And if I find out A transpose and again its transpose, so what am I going to get? A, C, B, and D. So again, so A is equals to, so basically A becomes equal to A transpose whole transpose. So this property you must remember. And let's say if I have A plus B whole transpose, then simply I can take the transpose of matrices and separately and then add them. Let's say if I have a constant multiplied K to the A matrix, again the constant causes no effect to the transpose of a matrix. Now this one is an important thing that you must remember. Let's say if I have A into B whole transpose, then this can be written separately as B transpose A transpose. So this becomes reverse. So first we put the one that comes at the last. Let's say if I had ABC whole transpose, then how would I write this down? This would have become C transpose B transpose into A transpose. So you must remember this thing, that while multiplying and after multiplying 3, let's say, matrices, and I have to find out the transpose of those 3 matrices together, then separately if I have to find out the transpose, then it would become reverse. It would become in reverse order. So this is an important property you must remember of transpose.